You got a minute. Good morning.
Morning. How do I know whether or not one of the kids dropped the clothes?
We can check that.
Okay.
Send me a message and I'll check it for you.
Mike Kalai is also going to be sitting in too.
Fabulous.
With you towards what he can get you. Do you know? Was it you that told me about this ball you throw around with the mic? He's going to check it. He's going to check up on that.
Fabulous.
They're supposed to sit here. One thing I just want to remind you again.
We're streaming.
What?
We're streaming.
Great. Anytime a kid asks you a question,
Yeah.
repeat it because everybody can hear you, and just assume no one can hear what the kid's saying.
You got it.
Okay? That's one thing I want to make sure you know.
Check, check. Check, check. Yeah, this is like a good backup because sometimes the other one. Yeah. Yep. On what? It's being printed. I've got it. Yep. Huh? It's on its way. Good morning. Thanks, bud. All right. There's enough setup for one day, huh? Good morning.
Morning.
Good morning. I'm Tony Farrar from the Mechanical Engineering Department. Today I'm going to show you a couple of coding tricks that are going to help you on Friday, where we're going to have our first in-class coding challenge, first code sprint of the semester. Thank you for being here. In addition, today's an exciting day. We're going to have our first visit from the Entrepreneurship Institute, and so they're going to give the last 10 minutes. So when I wrap up early, that doesn't mean run for it. We got an extra thing to tell you about today. All righty. So every problem that we face can be thought of in terms of inputs and outputs and some process that happens in between that causes the inputs to become the outputs we wanted. And let's see, a example of this might be making a pizza. And so the inputs for making a pizza are things like water and flour and pepperoni and yeast and tomatoes and all these ingredients. They move through a process, and out comes, we hope, a delicious pie. The thing that this class is going to focus on, after we've decided what our inputs and outputs are going to be, is the black box in between, the processes that are buried in there that cause these raw ingredients to become the thing we wanted. And so, for example, processes that might be happening in the black box for a pizza could be things like knead and mix and measure and spread and chop and bake. The goal is that we write such clear instructions that any idiot can go make a pizza, right? And that's the business model for an awful lot of pizza companies like Domino's and these places. We want a process that is so well defined that we can insert people and have them create delicious pizzas. That's not necessarily saying that everybody that works at Domino's is an idiot, so don't read that the wrong way. It turns out computers do this too. For example, maybe we input personal information and a list of a few of our favorite friends, and then this magical black box of an algorithm called Facebook takes those pieces of information and comes up with suggestions of more people you know. Kind of crazy. The one that gets me even more weirded out, though, isn't Facebook. It's actually LinkedIn, because that thing finds people, and I'm like, how does it know that I know these people? Because I haven't really put too much of my connection in there. The answer is the interesting program that's buried in their black box that's turning inputs into these outputs of recommended people to connect to. If we zoom out a level, we could really summarize all the different flavors of inputs and outputs on a pretty small list, right? Computers don't actually do all that much. It's interesting what they become, but in the end of the day, most of what we're dealing with are things like text and numbers and images and sound and video. These are the things that computers take in, process, and spit back out. Now, what that text means starts to get pretty interesting, right? Maybe that text is a book, or maybe it's a script for a movie, or maybe it's a list of numbers representing the grades in this class. So what I'd like to do today is explore what it is mainly that we can do with text and numbers. We'll get into the other things a bit later, but today we're going to talk about text and numbers, which are going to show up in Friday's code sprint. All right, so what can we do with numbers? Yeah.
Make people sad.
We can make people sad. Did you know what was coming? This is hilarious. Okay, so the first thing that you can do with numbers is you can store them in variables. So for example, I could say there's $1,000 in my bank account.
I really did not.
Spy. Okay, so that's the hacker that's stolen my identity. Everybody now knows. And so here's what's interesting, right? I've now associated a number with a variable. If I say, what's my account balance, you can tell me it's $1,000. Wouldn't that be nice? Right? The point is, these two things are now linked, and I don't have to use the word 1,000 anymore. I can say account balance, and you think 1,000. Other things that we can do with numbers include operate on them. These are things that actually change the value of the number, right? What are some things that you can do to change the value of a number? I heard add. Subtract, okay. We're getting there. What else does that calculator do? Multiply, divide, yeah. They stole your division, okay. Yeah. Oh, I heard that. Who said that? Modulus. What's a modulus? Yes. I'm sorry? Uh-huh. Yeah, so it has to do with being divisible by it. And we can go all the way back to like grade school concept for a second here. What number comes out of the modulus when you do it? The remainder. Cool. Okay, and we have one more that I'm fishing for. Exponents. Cool. Sorry, he jumped on you. What did you have? I'm sorry? Ceilings. And we can round them. Okay, I've overlooked some operations that we can do. Today we're going to talk about these. Add, subtract, multiply, divide, remainder, and exponent. So I know that we're doing things in different orders depending on which system you've chosen to go through. But have you seen things like addition and subtraction at this point? Is that like 90% of the people in the room or 12% of the people in the room? How are we doing? All right, so challenge number 1 for you today. I'm going to give you a 2-minute challenge here. Take something out to write on, piece of paper, whatever it is you like. And we're gonna do some programming the old school way. Paper and pencil, which is irritating because it won't underline itself in red for you if you type something wrong. All right, so I have 7 challenges to issue you here. And I'd like you to try and work them for yourself, but of course you could partner up with your buddy if you find yourself stuck. And then we'll come back together and I will show you the code that I came up with that answers each of these questions. So the first one is I'd like you to store a number, a value of 5, in a variable named x. The next thing that I'd like you to do is add 1 plus 2 and store it in a variable named a. Next, I'd like you to subtract 2 minus 3, store that in a variable named b. Then we're going to multiply 3 times 4, store that in a variable called c. We're going to divide 4 by 5, store that in a variable called d. We're getting there. 6 will be calculate the remainder of 31 divided by 5, store that in a variable called e. And lastly, raise 6 to the 7th power and store that in a variable called f. 2 minutes go. Well, 2 minutes plus 5 seconds because there's like a countdown here. So we'll be back together in 2 minutes. I'm sorry? The Jeopardy music. That would be much better than this little countdown clock, right? What we need to do is, movie previews are like 2 minutes long, right? We could just grab movie previews and say you have till the end of this preview to. There's no distraction there. Does silence mean everybody knows what they're doing? All right. Pencils are moving. Yeah. I don't know. Ah, interesting. You don't have to call a class. This isn't like closed notes. You could ask the interwebs. Huh? You can Google that. You can Google that.
The best resource in the world is standing right in front of me.
I'm the best resource in the world. That won't get you extra credit.
You have access to like a great library of Alexandria.
I do. You're right. And since that exists in our pockets, the Great Library of Alexandria. Morning. Where's it going? The what? I'm checking it as we go. I want to check it as we go. I want steady level progress. Yeah, you can go through your... We need to come up with a system there. I'll ask people today how we want to do it to keep it simple. Cool. All right. How'd this go? Boom. Okay, so first thing I wanted to show you, and then we'll get to the solutions here. If you're writing JavaScript on your computer, one of the neat things is you don't need any software that isn't already built in. All you need to play with JavaScript is a text editor and a web browser. And so this is actually an HTML file that will call my JavaScript file named operators and execute it if I were to open it in a web browser. So I'll make sure this gets posted. You can literally copy and paste this, and all you would need to do to get your code to work is change this file name to match whatever you created as a .js file that has your code in it. And you can run it, and it'll do whatever it is that you asked it to. Okay, so problem number 1 was store a value of 5 in a variable named x. How'd that go? Yeah.
Originally say
I think so. Maybe not. Maybe not. Who's got it? Yeah.
I had var x is equal to 5, and then a semicolon.
Var x equals 5. Semicolons optional in JavaScript, not in other languages. So I left them out here just to keep the slides clean, but you can do it either way. Yep, cool. And then if we wanted to see that value, I could either type alert x. If I run that, what's going to happen? We get a pop-up window. Or what's the other option? Console.log of x, and that prints it to a console, which is behind the scenes hiding in your web browser. But like things like Firefox Developer Edition, you can go download and actually pull that up and look at it. And so we got a value of 5 stored in x. There's my little pop-up window, and we move on. We can use return. Will send it somewhere else. Will it actually print it anywhere? Not unless we call a function that prints it. So return, which shows up in the HackerRank assignments, all that does is take that value and send it back to the rest of your computer to understand that it's there. Okay, so how about this one? How do we do this one? 1 plus 2, stick it in a variable named a. Yeah. Var a equals 1 plus 2. All right. And then once again, we could look at it using alert, or we could use console.log. If I run the alert, what's going to pop up? A 3. Hey! All right, cool. Number 3 here, subtract 2 minus 3, store it in a variable named b. Not you. Somebody tell me the answer. I got all day. They're paying me to be here. Yeah. Var b equals 2 minus 3. All right, we're getting there. And once again, we could print it using alert, or we could use console.log if you're not into having lots of pop-ups. You could imagine if we ran 12 of these in a row, pop, pop, pop. It gets old quick. Console's nice. And we get -1 there. And we can go through the rest of these. So far, all we're really doing is changing the letter and the operator. Multiplication looks like a star. 3 times 4. Remind me of my arithmetic here. What am I going to get? 12. Okay, cool. Just making sure we're awake. All right, we got division here. That's just the divide sign, the slash. And too much animation in your slides, Dr. Farrar. 4 over 5 is 0.8. And then number 6, this is the remainder. Somebody already said it, but what's the symbol for the remainder? Yeah. A percent sign. Cool. So 31% 5. Once again, we can print that using alert or console.log. What am I going to get here? Ooh, now there's math we haven't done in a while. Yeah, a 1. Cool. Right? 31 divided by 5 is 6, remainder 1. 6? Yikes. One more cup of insert coffee here. Okay, raise 6 to the 7th power. Did anybody figure out how to do an exponent in JavaScript? Yeah, what do you got? A caret? Who says caret? Who says something else? Something else? What did you have? Math.power. Okay, now we're getting into classes and math things there. Okay, who had math.pow? Okay, I think that one will actually work. What else is there? There's another option. Yeah. Double multiplication stars. I'm pretty sure that the caret will throw an error because it means something else in JavaScript. So double stars is the way to go there. 6 to the 7th, if you didn't do that in your head before I printed it, was 279,936. That'll be on the exam. So here's my whole code for all of those problems. And the alert box causes these pop-ups to happen. And in Firefox Developer Edition, you can have it show the console, which looks like this. And so this is the actual website, and then this is built-in tools that you can pull up from the bottom. So there's probably ways to do this in the other browsers as well. I just know how to do it here, and so there it is. So this is the entire script showing all of those outputs, and it didn't go one at a time with a pop, and I had to click OK, and then pop and click OK, and so on. So this is a great way to debug your codes. Okay, operations on variables. I'm only going to give you 1 minute this time. We're going to go a step further in the complexity now, and we're going to store a value of 5 in a variable called x. We're going to add 4 to that value, and then store that in a variable called y. And then the second one we're going to do is store a value of 5 in a variable named x, add 1 to the value stored in x, and update the value stored in x. 1 minute plus 5 seconds, go. Time seems to be working. Morning. How's it going? Great, great.
I like the moving around. Hey, I said to him, you have the laser. You don't always use the laser. Try to hold directly inside.
Yeah, the problem is it doesn't show up on the streams, and so when you say things like, look here,
Whatever you can, just try to use it.
yeah.
Now, are these, since we talked, or did you do these slides? Because these are fine.
I did grow the font.
Well, this is
I
great.
discovered that I could use widescreen and it would show up, and that gave me some
These are
room.
fantastic. I mean, let's see this. Yeah.
I did. I tripled the font size.
Oh, there's a big difference.
Yeah.
Just 2 days.
Fabulous.
Yeah, I'm real happy with this. And I think only once or twice someone said something and you didn't repeat it. You're just gonna have to get into the habit of doing it. But he's gonna try to get you that ball.
I want that thing. That'd be cool, wouldn't it? It's off. It's like a foam ball with a mic. Yeah.
Well, quick question. You said you're streaming this.
Yes.
Is it get archived?
Yes.
Oh, great. And the kids know that?
Yes. It's on Facebook and YouTube, and they can go back and watch it.
Perfect.
All right, 16 more seconds. Who's stuck? You doing okay? Three, two, one. All right, so who's got a solution for me on problem number 1? We're going to store a value of 5 in a variable named x. We're going to add 4 to the value stored in x and store that in a variable named y. Help me out. You just got voluntold, man. What you got? Variable x equals 5. Variable y equals x plus 5. Var x equals 5. Var y equals x plus, sorry, misspoke, x plus 4. That was 4. Now, if I want to see this, what do I type next? Alert y or console.log. Does anybody see the logical error in my code? There's an X there. So what's this going to actually print? What did I wish it would print? A 9. When you're debugging your code, sometimes it will yell at you because you typed something that the computer doesn't understand. Those are usually syntax errors. Right? You actually broke a rule. You used a command wrong. Here, I just asked for something other than what I wanted. Now, the irony is that I typed it wrong on the slides. I typed it right in my code, so I'm pretty sure we're going to get a 9. Cute, right? All right, second problem. Store value 5 in a variable named x, add 1 to the value of x, and update the value stored in x. Who's got this for me? Yeah. Var x plus equal 1. How'd the 5 get in there? I'm sorry? If it's the same function, maybe it's already in there. In that case, you wouldn't want the var again because that would overwrite it. Okay? Yeah, wait, I saw a hand over here first. I'm sorry, I didn't mean to. Nope. Okay, over here. Yeah, go ahead. Var x equals 5. And then x plus plus. So that's a fancy built-in trick for JavaScript. Some languages support things like that. Others don't. I've got two solutions here. I wasn't sure which one you'd get to first. What's the other way I could do it? Yeah. X is equal to x plus 1. So we can go x equals x plus 1. You won't see the word var again because it's already been defined here. And if I wanted to peek in there, I can do alert x. I can do console.log of x, and up would come a 6. Sneaky trick number 2 is actually where you went first, and that was var x equals 5, and then just the command x plus plus. That's a complete statement that says take the value of x, increment it by 1, and replace the value of x. So there's at least two ways to have done that one. And once again, the alert boxes come up to tell us how it works. Okay, so here's the real test now. We're going to smash together a little bit more concepts. Okay, this is the range equation for a projectile. So now we're launching cannonballs over at Drexel. This is how it's going to work. Here's your conditions. Okay, we're going to use JavaScript to calculate the range of a projectile. The initial velocity v0 is 12. Acceleration of gravity is 9.8. That's this g. And we're going to use an initial angle of 45 degrees, which is going to save you a little trouble because the sine of 45 times 2 just happens to be 1. So I'm going to give you a minute here and then see how we ended up. So write me a program that launches things at 45 degrees. About 20 more seconds. The units, now you can just do the numbers. I made sure the units worked for you. Didn't I? Uh-oh. Okay. All right. Yeah.
Do brackets, do they work the same way they do?
Yep. Well, parentheses, not hard brackets. Yep, yep, yep. We have to start distinguishing there a little bit. All right. Whoa. Don't give the answer away. Oh, now I got to go through this again. How'd we do? How many did all the math on a calculator first? A couple people, okay. I was tempted to do that myself. Somebody else, tell me what you did. All right, go. I'm sorry? Yeah? All right, you said a thing called var v equals 12. Okay. V equals v star star 2 to get it to raise to the second power. Okay. Var g equals 9.8. I'm sorry, did you say var in front of the math operation there? Or well, you said var g, var v equals 12. And then you said v star star 2? V equals v star star 2? Okay. Yep. And then we got g. Var answer is v divided by g. Okay. That's pretty similar to what I had. So I called it v0. And then I had g in there as well. Oh, here I use 9.81 because I'm just more precise, I guess. How many people think you could do all the math in one step? Couple. How many people did it in multiple steps? Saved it in intermediate variables as you went, like a couple times, or we update v a few times? Yep. Either way works. The challenge is if you're updating the original values, then you couldn't reuse that. Maybe there's some other equation later in your life that you want to reuse the value of v for. And by overwriting it v squared, you've changed that original condition. So I like, when I'm doing especially engineering problems, I like to keep my original variables unchanged. And then just order of operations wise, if I throw some parentheses on this is all the operations that you suggested. But I was able to smash it into one line and save myself from having to save some intermediate values. And then we could, print that thing like so. So this is one where there's definitely more than one way to do it, but this is one compact way for sure. Okay. The next thing I want to tell you about is conditional statements. One of the interesting things that computers can do is they can decide how two numbers are related to each other. So what are some ways that things relate to each other? Well, we have equality. JavaScript has an extra special equality. Has anybody encountered it? Yeah. I'm sorry? Okay, so we have inequalities as well. Yep, those are going to show up. And I've got these in order, sorry. The next one is also that we can do a thing where we check variable types. This gets interesting because you could have the character 3 or the value 3. And they're not quite the same thing, right? One's a string and one is a number. And then, so yeah, we do have not equal to, we have not equal to or not equal type. And let's see, we got greater than, less than. Too many animations in your slides. Greater than or equal to. What else? Less than or equal to, and the word and. Right? We could check more than one thing at the same. And what's that? Or. And I think I'm out. Okay, so now, nope, I'm not. There's also not. Okay, so JavaScript has specific operators for checking all of these conditions. Okay, what's an equal sign look like in JavaScript? If we want to check if two things are equal. Yeah. 3 equal signs. Agrees, disagrees? Half and half? Yeah. He thinks it'll be 2. The answer is both, but in a certain order. So checking if things are equal is just a double equal sign. Checking if they're equal and have the same data type. If it says 3 and they're both integers, for example, that would be the triple equal. A lot of languages don't have this. JavaScript's a bit unique in that. Not equal to, we use an exclamation point. Gave that one away before I asked. So what do you think not equal to or not equal types is going to look like? Yeah. An exclamation point and 2 equal signs. Cool. How about greater than? Haha. And less than? Did that work? Greater than or equal to? Greater than or equal to? Yeah. Add an equal sign. Does it matter whether it goes in front of or behind? It does. Okay. Some languages it does, others it doesn't. Which order does JavaScript want it? Like you would read it to, greater than or equal to. So you actually need it to be greater than, equal to in that order, or less than, equal to in that order. How do we do an and? Yeah. Two and symbols. How about an or? A what? A double pipe. That's the vertical thing. And the basic not. Somebody blurted exclamation points. There we go. Cool. Okay, so I had two more ideas. We're going to do one of them today, and we'll get to the rest of it next time because I want to make sure that we have time for our entrepreneurship guest. I want to give you another minute, not two. We're going to do one more minute here, and what I want you to do is tell me what my program does. And go. I'm sorry? An exclusive or? I think so. I would have to Google it. I don't know off the top of my head. I have to check that one. It probably does. Good morning. Good morning! So I've got a minute and a half here, and then it's all yours. Cool? Hey, how's it going? Yeah. Another half minute here. Probably. Yes. Yeah, I update them right after class just in case there's any punchlines. I don't want to give it away. Yeah. All my jokes would be gone if you had the slides, right?
No, they're on Facebook.
Oh. Our goal is once every time you turn something in within 24 hours, it should be updated. If send an email with an exclamation point or two in it to code help. We're still setting up our system there, so it's manual at the moment, and there's this many, so we had 300 grades to type in presumably every day. So, but we're writing code for it. All right, how we do? How many people think this is just going to throw an error message? A couple hands raised for the error message. How many people think the word hello is going to be displayed? Not too many. How about the word goodbye? All right, we got more hands there. How about the word weird? All right, we got lots of hands there. Did anybody raise their hand for weird but not goodbye? That'd be an interesting case. And yeah, because I am weird. And last, did anybody think that the answer is nothing happened? One or two. All right, so let's check the logic here. We have values of x equals 5, y equals So if x is equal to 5 and y is equal to 14, is the first case true? 5 greater than 14, so that's false. So it jumps from there down to this else if line. Now we're checking if x is smaller than y. Is that true? 5 less than 14? Sure. So that's what causes goodbye to be popped at us. And because now we're hiding inside this if statement, there's a new buried if statement here that says if z is not equal to 13, is z equal to 13? No, so we get a true for this one. And if y is bigger than z, is 14 bigger than 10? Yes, so we get a true and a true. When you and two trues together, that's also true, which causes weird to pop up. And because we hit those, we automatically skip the else statement and nothing else happened. So this one does not get printed. So the answer there is goodbye gets printed and weirdo gets printed. Cool, thanks for playing along, y'all. I am going to chop myself off at this point and remind you that that doesn't mean we're packing up. It just means that we're skipping ahead slightly as I bring our guest up. And yes, these slides are posted, so you'll be able to see them on Canvas. Friendly reminder here. You should have 3 more modules done by Monday, which means your total number done by Monday is 6 modules. If you haven't, it's time to get busy. I would now like to invite Alan Kersner from the Innovation and Entrepreneurship Institute. They're going to be interfacing with this course a few times this semester as we move forward and help us find problems and solve them. Yes. Hey! On Friday, you should bring your laptop because you have to code and turn something in with it. A few of you may be getting emails from your team leads to meet elsewhere so that we have enough room to spread out, follow those instructions as well. And microphones here.
Any of them carryable? No, I got
I've got a clicker that does exactly what I was going to do.
Okay. He's going to the same place?
It switches, it flips. Sorry.
That's okay, I'm not technical.
There we go.
All right. Yeah.
Keys work.
Okay. And they know about the whole module.
We're on our way. Yeah.
Okay, so can everyone hear me? Yes? Yes, in the back? Okay. So as the professor has told you, we're going to be going through both Rob McNamee, who heads up the Entrepreneurship Academy, and myself, about 5 classes with you, and your TAs are going to be working with you. And the goal really is to help you as you create your apps to be more successful. And what success requires, who here plays Crazy Birds or whatever it is? Angry Birds, whatever. Just birds? Okay. Successes like that are very rare, right? And they become almost a fad because students like you and in high school and everything and adults get obsessed with it and addicted to it. But that is much more the exception rather than the rule. So what we will be working with you on is really the key to success in any proposition, whether it's for-profit or not-for-profit, and that is delivering value. And you may say, you know, can I create value and how? And the way you create it is by meeting unmet needs and desires. So, anyone here have a hard time getting up in the morning and getting to class on time? Yeah, all right, okay. So a real way to create value would be figure out how to make it easier for you and your peers to get up in the morning and in class at time. And if that app ensures that you're in bed by 10 p.m., haha, then that would be a valuable app, right? Or if it's like my son who you can't get up, I actually got him a thing that it shakes the whole bed like it's, I think, a 6 on the Richter scale earthquake. No, this is the truth. And he has a siren, which is basically like a major fire alarm going off. And he actually gets up. And now he's at graduate school, and he has his own apartment, but he's so afraid that everyone in the next apartments will hear it, he just does the earthquake shake. All right? So that's delivering value. So you can think of something, hopefully that's app-based, to create value like that. What am I doing here? Okay. So if you can fulfill these needs and desires better than existing options out there, then you're creating value. All right? So we don't have time. We won't go through it now. We'll go through in much more detail as we move forward. But as you go through your life, look at what you're doing. Look at what other people are doing. And say, can I make that better for them or for myself? So one thing I always hear about is you can't get a healthy lunch. As a matter of fact, we had it in one of our sessions with the TAs. You can't get a healthy lunch around here. Well, whether that's true or not is up to debate. But if that's an unmet desire, and if a bunch of you want to eat healthier and you don't, how can you make that happen? How can you make it happen in a more convenient, easier, and potentially cheaper way? That would create value. Okay? Okay, so at the end of the day, providing value equates to success. People or companies, whoever you're targeting, or philanthropies, are going to use your app. And when they use your app, that leads to profits and a big payday. And you may be saying, oh, that's all great to talk about, but what can we do? You know, we're here at Temple, we're in an old building, and it's early in the morning. But there have been some giant successes by college students. And Reddit was started by a college student. His first idea was rejected. He was actually in a class, somewhat like this, and was rejected. And then he and his partner came up with the idea of an entertainment site, basically a clearinghouse for entertainment news. And this is a bit old. In 2006, he sold it to Condé Nast, which is one of the biggest magazine publishers, for $20 million. Anyone recognize that ghost in the corner? Snapchat. All right? Another college guy started that. Now, he hasn't sold yet, but he has 178 million daily users, and his company values $17.6 billion. Yes, sir?
Calculate a company's value when it's a free app that
Okay, well, in this case, they're publicly traded. So you literally can go on Google and say value of Snapchat, and it'll give it to you, the number of shares that are outstanding and the price per share. And this is as of yesterday. And even though the app does nothing, it may be free to a user. But as you mentioned, advertising dollars, very profitable, right? And as we move forward, and I got to speed up, we'll talk about that's a what we call a multi-platform business model where their job is to create eyeballs, and they do it for free, and then they sell their advertising or their access. Facebook, we don't have to talk about. Everyone's tired of hearing about Zuckerberg. All right. My recommendation to you is a lot of us just create standalone apps, right? It's an app that's fun, that we play with, that just tells us what the weather is. But your real key to increasing value, and I'll say a bit of a bigger challenge but more rewarding, is do an app that helps create or sustain a business. So right here, and we may get him to speak in the next couple of weeks, Temple Grad has started Habitat through an app. Anyone here use Habitat? Oh, only a couple of you. All right. Well, it basically delivers food from the food trucks and some restaurants around here. All app-based. People were saying they want to go to a food truck, they don't have time, so we deliver it. Instacart was started by a student in New York. Basically, I could sit home, order my groceries, and I don't have to go pick them up. They actually hire people to go shop for you, and then they deliver those to your house. And then we don't have to talk about Uber, right? Uber's an app, but Uber's an app with an amazing business behind it. So as you go forward, think of what app really opens up business opportunities for you, or again, nonprofit opportunities. All right. Next week, this time, we're going to have a gentleman who founded Pinpointer. He won the BYOBB, Be Your Own Boss Bowl contest. He's app-based. He'll come and talk. And then moving forward, we're going to go through design thinking and customer empathy as exercises to help you. Thank you.
Yes. Let me fix your stuff at the beginning. We'll do it at the beginning. Perfect introduction.
There's a little more inspiration.